Article 230.2 of the National Electrical Code, or NEC, permits more than one service to a building under specific conditions. One such condition is when the total service load exceeds 2000 amps. The question arises whether these multiple services can enter the building on opposite sides and if the service disconnect means can be located in different rooms. The answer to this is yes, provided that all applicable requirements of the NEC are met. Firstly, it's essential to understand what constitutes a service. A service is defined as the conductors and equipment that deliver electric power from the serving utility to the wiring system of the premises served. This includes the service conductors, metering equipment, and the service disconnect means. When the total load of a building exceeds 2000 amps, it may be impractical or even impossible to supply the entire load through a single service. In such cases, the NEC allows for multiple services. The allowance for multiple services exceeding 2000 amps is based on practical considerations. Large buildings often have substantial electrical demands, and supplying the entire load through a single service could necessitate very large conductors and equipment. This can be costly, difficult to install, and may not be the most efficient design. By using multiple services, the load can be distributed, reducing the size and complexity of the individual service components. Secondly, the NEC does not explicitly prohibit services from entering a building on opposite sides. The primary concern is ensuring that each service complies with all applicable requirements for overcurrent protection, grounding, and disconnect means. The location of service entrances should be determined based on factors such as load distribution within the building, accessibility for maintenance, and coordination with the building's physical layout. It is permissible to have multiple service entrances located in different areas of the building. Thirdly, the NEC addresses the location of service disconnect means. The service disconnect means is the switch or circuit breaker used to disconnect all ungrounded conductors of a service from the premises wiring. This is a critical safety feature that allows for the electrical system to be de-energized for maintenance or in the event of an emergency. According to the NEC, the service disconnect means must be readily accessible and located either inside or outside the building at a readily accessible location nearest the point of entrance of the service conductors. This requirement ensures that the disconnect means can be quickly and easily accessed in case of an emergency. The NEC allows for multiple service disconnects when there are multiple services. In such cases, each service must have its own disconnect means, and these disconnects must be grouped together or located in close proximity to each other. This arrangement allows for all services to be disconnected simultaneously, which is important for safety. The NEC does not explicitly prohibit locating service disconnect means in different rooms, but it is important to consider the practical implications of such an arrangement. If the disconnects are located in different rooms, it may be more difficult to disconnect all services simultaneously in an emergency. For this reason, it is generally recommended to group the service disconnects together in a single location, such as an electrical room. However, if the building layout makes it impractical to group the disconnects, it is permissible to locate them in different rooms, provided that each disconnect is readily accessible and clearly labeled. In addition to the general requirements for service disconnects, the NEC also has specific requirements for overcurrent protection. Each service conductor must be protected by an overcurrent device, such as a circuit breaker or fuse, that is sized to protect the conductor against overloads and short circuits. The overcurrent device must be located at the point where the service conductors receive their supply, or as close as practicable thereto. The NEC also has requirements for grounding and bonding of electrical services. The grounding system is designed to provide a low impedance path for fault current to return to the source, which helps to trip overcurrent devices and prevent electrical shock hazards. The grounding system must be properly installed and maintained to ensure its effectiveness. The NEC requires that the service equipment be grounded to a grounding electrode system. This system typically consists of one or more grounding electrodes, such as ground rods, metal water pipes, or concrete encased electrodes. The grounding electrode system must be connected to the service equipment with a grounding electrode conductor. The NEC also requires that all metal enclosures and equipment be bonded together to create a low impedance path for fault current. Bonding is the process of connecting metal parts together to ensure that they are at the same electrical potential. This helps to prevent voltage differences that could create a shock hazard. The bonding system must be properly installed and maintained to ensure its effectiveness. In addition to the requirements for overcurrent protection, grounding, and bonding, the NEC also has requirements for the installation of service conductors. Service conductors must be installed in a raceway, such as conduit or electrical metallic tubing, to protect them from physical damage. The raceway must be properly supported and secured to ensure that it does not sag or pull on the service conductors. Service conductors must also be sized correctly for the load they will be carrying. The NEC provides tables that specify the minimum size of conductors for various ampacities. It is important to use the correct size conductors to prevent overheating and voltage drop. When installing multiple services, it is important to coordinate the installation with the serving utility. The utility will typically have specific requirements for the location of service entrances and metering equipment. It is important to contact the utility early in the design process to ensure that the installation complies with their requirements. In summary, Article 230.2 permits more than one service for a building if the total service exceeds 2000 amps. These services can enter the building on opposite sides, and the service disconnect means can be in different rooms provided that all applicable requirements of the NEC are met. This includes requirements for overcurrent protection, grounding, bonding, and the installation of service conductors. It is important to consult the NEC and local codes to ensure that the installation complies with all applicable requirements. The allowance for multiple services is based on practical considerations related to the size and complexity of large electrical systems. By using multiple services, the load can be distributed, reducing the size and cost of individual service components. However, it is important to carefully coordinate the installation to ensure that all services are properly protected and grounded. The NEC provides detailed requirements for the installation of electrical services, and it is important to follow these requirements to ensure the safety and reliability of the electrical system. Firstly, the location of service entrances should be carefully considered based on factors such as load distribution, accessibility, and coordination with the building's physical layout. Secondly, service disconnect means should be grouped together or located in close proximity to each other whenever possible to facilitate simultaneous disconnection in case of an emergency. Thirdly, all service conductors must be protected by overcurrent devices that are sized to protect the conductors against overloads and short circuits. Fourthly, the grounding system must be properly installed and maintained to provide a low impedance path for fault current to return to the source. Fifthly, all metal enclosures and equipment must be bonded together to create a low impedance path for fault current. Sixthly, service conductors must be installed in a raceway to protect them from physical damage. Seventhly, service conductors must be sized correctly for the load they will be carrying. Eighthly, the installation must be coordinated with the serving utility to ensure that it complies with their requirements. By following these guidelines, it is possible to safely and effectively install multiple electrical services in a building. When dealing with electrical systems exceeding 2000 amps, it is crucial to prioritize safety and ensure compliance with all applicable codes and regulations. This often involves consulting with qualified electrical engineers and contractors who have experience with large-scale electrical installations. These professionals can provide valuable insights and guidance to ensure that the electrical system is designed and installed in a safe and reliable manner. The National Electrical Code serves as the cornerstone for electrical safety in buildings. Regular updates and revisions to the NEC reflect advancements in technology, evolving safety standards, and lessons learned from past experiences. Staying current with the latest edition of the NEC is essential for anyone involved in the design, installation, and maintenance of electrical systems. Local jurisdictions often adopt and amend the NEC to address specific local conditions and requirements. It is important to be aware of and comply with all applicable local codes and regulations in addition to the NEC. Permit and inspection processes play a crucial role in ensuring that electrical installations comply with code requirements. Obtaining the necessary permits and undergoing inspections by qualified electrical inspectors helps to identify and correct potential safety hazards before they can cause problems. Electrical systems should be inspected regularly to identify and address any potential issues before they escalate into major problems. Regular maintenance, such as tightening connections and replacing worn components, can help to extend the life of the electrical system and prevent costly repairs. Electrical safety training is essential for anyone who works on or around electrical systems. Training programs provide workers with the knowledge and skills they need to identify and avoid electrical hazards. Lockout/tagout procedures are critical for preventing accidental energization of electrical equipment during maintenance or repair work. These procedures involve disconnecting the equipment from its power source and securing the disconnect device with a lock and tag. Personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools, should be used whenever working on or around electrical systems. PPE helps to protect workers from electrical shock, arc flash, and other hazards. Arc flash is a dangerous electrical phenomenon that can occur when a short circuit creates an arc of electricity. Arc flash can cause severe burns, blindness, and even death. Arc flash hazard assessment should be conducted to determine the potential arc flash hazards in a facility. The results of the assessment should be used to develop arc flash safety procedures and select appropriate PPE. Electrical safety is a shared responsibility. Everyone who works on or around electrical systems has a role to play in ensuring that the work is done safely. By following safe work practices and complying with all applicable codes and regulations, it is possible to prevent electrical accidents and injuries. In the context of NEC Article 230.2, which allows multiple services exceeding 2000 amps under specific conditions, these general safety principles become even more important. Large-scale electrical installations require meticulous planning, execution, and ongoing maintenance to ensure the safety and reliability of the system. When multiple services are involved, it is crucial to coordinate the installation and maintenance activities to avoid conflicts and ensure that all services are properly protected and grounded. The placement of service disconnect means in different rooms can create challenges for emergency responders who need to quickly de-energize the electrical system. It is important to clearly label the location of each disconnect and to develop procedures for coordinating the disconnection of all services in an emergency. The use of multiple services can also increase the complexity of the grounding system. It is important to ensure that all services are properly grounded and bonded to create a low impedance path for fault current. Regular inspections and testing of the grounding system are essential to ensure its effectiveness. When planning for future expansion or modifications to an electrical system with multiple services, it is important to consider the impact on the existing services. Adding new loads or modifying existing loads can affect the overall load balance and may require adjustments to the service capacity. It is also important to ensure that any new services are properly coordinated with the existing services to avoid conflicts. In addition to the technical aspects of electrical safety, it is also important to foster a strong safety culture within an organization. A safety culture is a shared commitment to safety at all levels of the organization. It involves creating an environment where workers feel empowered to identify and report safety hazards without fear of reprisal. It also involves providing workers with the training and resources they need to work safely. The NEC provides a comprehensive framework for electrical safety, but it is not a substitute for sound engineering judgment and safe work practices. It is important to carefully consider all aspects of the electrical installation and to implement appropriate safety measures to protect workers and the public. By following these principles, it is possible to safely and effectively manage electrical systems with multiple services exceeding 2000 amps.